Hi, my name is Dominik Berndt, Technical Sales Manager at Zurich Instruments, a daughter company of Rohde Schwarz. Today I am very happy to introduce you to the low ESR and ESL measurement capabilities that we provide with our MFIA impedance analyzer. You might be working on traction inverters and therefore want to study the ESR and ESL characteristics of your DC-link capacitor, which is included in the inverter stage. Usually, these values are only specified at a fixed frequency specified by the component manufacturer, but for your application, you might be interested in a more comprehensive understanding of these parameters, for example, as a function of frequency. The MFIA is the perfect instrument for characterizing DC-link capacitors, as it covers a very broad impedance range starting from 1 milliohm and below, and this in a very fast time thanks to its innovative FPGA-based architecture. Employing our LabOne instrument control software, it is possible to access a comprehensive toolset comprising of sweeper, plotter, oscilloscope and many more tools. With this, it is possible to record multiple parameters such as ESR, ESL, but also the capacitance of the capacitor or the tangent delta and many more in parallel. To accurately measure such low values, a proper fixture is required, such as this one. This is designed to fit spade connectors, and please, for the choice of your fixture, look at the component that you want to characterize, since the positions and the connectors might vary from component to component. First of all, we have to perform a short user compensation. Therefore, I have this short connector plate, which I will insert into the fixture. And then we have to perform a frequency-dependent calibration routine, which can be seen in our instrument control software. I will click to compensate now. And this frequency-dependent calibration routine ensures that the contact resistances and the remaining self-inductivities of the fixture are eliminated. The routine then records a measurement baseline, which is subtracted from the real measurement by the software. Those compensations can be performed shortly before the measurement, or can also be saved as a compensation file for your convenience. Let's start now by performing a frequency-dependent study of the DC-link capacitor. For this, I will connect the DC-link to the fixture. And let's have a look at the frequency range that is relevant for the DC-link capacitor, which is starting from 1 kHz. Usually the switching frequencies of the IGBTs are in this range, going up to 5 MHz. We can employ different equivalent circuits, which are the basis of the calculation of the impedance-related parameters. For the ESR and ESL characterization, we choose a serial representation of the resistor and an inductor. Then let's directly start the sweep, which records a frequency-dependent characteristic of the DC-link capacitor. For the DC-link capacitor, the ESR measurement is mostly relevant in the lower kilohertz range that we can see here for the ESR values, and starting from the resonance frequency of the capacitor, also the inductive contributions start to play a role here. It is clearly visible that the ESR firstly is at a constant level. We can also do some specific measurements at a fixed frequency here, for example at 8 kHz and 25 kHz, and we can obtain some inductive peaks here in the higher kilohertz range. Both ESR at a specific frequency and ESL peaks can be directly obtained using the math tools implemented in our software LabOne. These traces can afterwards also be exported in various formats for re-import later, for example to study aging effects of your component, or just to have an eye on repeatability and reproducibility of your measurement. Of course, it is also possible to do a time-dependent view. This can either be done via the numeric tab, which you can see here, or more conveniently via the plotter tab, which again gives you a statistical analysis to obtain values like the average, min-max values, or the standard deviation, which in turn gives you also a hint on the precision of the measurement. If you need any support on any of these topics, please reach out to us. We have dedicated application scientists and engineers helping you to find the best measurement solution for your problem. Thanks for watching.